Hi, welcome back. Today's lesson is about the serial port in microcontrollers. The first part of this video, I will cover some of the serial port characteristics, what is it for, and how to use it. The second part, I will make a demonstration on programming using serial port on the big microcontrollers. So get started. The serial port is an interface that helps you to transmit or to transfer data between one MCU or one microcontrollers to the other device or the other microcontrollers or a PC or some device. So in order to use the serial port, that means the data will be shipped out over the line like this. This is the connection between the two devices. So here you have the transmit pins. We use only one MCU pin to send data serially to the receiver here, to the RX or receive pins. And then you have two configurations for this, because the first configuration, if you want to ship the data out, you have to measure how long does it take to make 1 bit to send, or the transmission speed. So in the synchronous, they use a pin as the clock generator. So you have here a device that generates the clock. We call it the master or the transmit device. And here we have receiver or slave that receive the clocks, and it will listen to this clock. Either one pulls up a clocks to make 1 bit for the data. So we have the data shipped out with the measurement time by the clock pins generated by the master. The second configuration is the asynchronous. Asynchronous, we have to predefine, or we have to make the transmission speed for the transmitter and the receiver would be the same. So if we can predefine between the two devices with the same speed, you can send data without the clock pins. So in order to send data asynchronous, we have to handshaking. All right, so we make it the start bit here and the stop bit here to make the data between the packets, so that the receiver, he knows when will the data will be sent. Okay, and we have the other characteristics like the flow control, handshaking or something. All right, you can read more at the book I post in the courses. This is a very good book to read for the serial port reference. In the microcontrollers, in the big microcontrollers, you can using the transmission as they have is the TX pins. So if you write data into TX register right here, it will be shipped out to the pins, and then there are some bit or RAMs in a RAMs to make you control the whole process of transmission. Where you have here the baud rate is the speed, the transmission speed. They call it the baud rate. Is they count it as how many bits in a second the transmitter will be transmit to the receiver. So for example, it 9,600 bit per second. For the receiver, you have the RX pins, okay, where the data comes, it will read into a buffer right here, the RC register, Okay, inside a RAMs will keep the data from the RX pins. Okay, and then you can read this register to make your programming work. Of course, there are some other register in a RAMs to control the whole process of receiving. Okay, now we goes to the next part is the demonstration. We use the MCC or MBLAB X code configurator to make it generate, for example, USART initialize to make a define for baud rate or the checking data is ready or not, and here the USART write. You have data you want to send, then you write by using these functions. The similar with the read functions, where you have data in the read buffer, then you read into a variables. Okay, we start by start up a MCC. Alright, we save it. Then I select my configuration. Okay, the internal.
1 minute. The auto function turn off because I don't use it. I want to turn it off. Alright. Okay. We can generate.
Alright then, we have the main programs and the other function already generated for us. Okay, the header files. Alright, then we go to the USART libraries right here. We double click. Okay, we have it here. Then where you have the baud rate selection here, I select the default values and I enable the transmit to make it transmit to have the function for transmission, and here the receive. Okay, the other function you can turn on or turn off is the table here or the guide here. Okay, that's it. We generate the code. Alright, then we will have the USART.c and USART.headers right here. We can open it. Alright, they're my functions. Okay, data ready or initialize. Okay, TX ready. Here is the example on how to use it. Okay, and now this is the body of the functions. Okay, it's the initialize. Okay, and the other functions ready, so they just check a flag, the interrupt flag for receiving, and the USART read. Okay, see, checking some errors, and if it's not, just read a RAMs, a RC register. And the other functions for write, they just take the data in and then write it or assign it to the TX register. Very easy. So now we take a demonstration for sending, okay, data. I want to copy this to send data, copy, and then paste to here. For example, I want to send 65. Okay, 65. So I will send the number 65 in decimal system to my TX pins. Okay, this is my pin managers and the grid viewed. Okay, I want to change it to this one, SSO, and there you can see the RX automatically selected or locked, and TX for RB7, RX for RB5 on my microcontrollers. Okay, there we go. Here's my hardware. It's the RX pins and here is TX pin. So I have already taken out the virtual terminal for debug the terminals. Is the RX and TX will be connected to the virtual terminal here, and I have the other COM pins is a software from Protus. It can communicate between Protus is the software, and it's sent to the hardware or physical port. Okay, we will make it later. Then this time we select the baud rate, so we have to predefine the receiver and the transmitter would be the same baud rate or same speed. Okay, then we make a little delay here, 500. Okay, and then translate. All right. Okay, we run the programs. All right. It will send the number 65, and as you can see here in the ASCII table, the 65 number would be uppercase of A, okay, or in the hex display it would be 41. Okay, you can check for opening the ASCII tables. All right, see me later. All right, where is my 65? 65 right here is in character A. Okay, if you send 64 for example, you can check it. 64. Okay, then it would be the @ characters. Okay, right here. Or if you want to send a number with the display or representative of the ASCII table, you can simply use like this. Okay, for example, I send the number character. Okay, so it will convert to the number and then it will send out. Let's check. Okay, so if you want to send character, let's put in a dash here for B, for example. Okay, let's check. All right, then what if you want to send a message or a string? Okay, then we have the support. We have the special function, the printf. Okay, in order to use a printf, you have to include the libraries for this function. So we have to include this one, the standard ios.h, into the programs right here. Okay, and then the second things, you have to have the put charge functions. Okay, so this printf function will use the put charge to generate or to send data. So let's copy it and then we define in our function. So here is the function for checking for busy. Okay, busy, then wait here. Okay, then in our functions, what is the function for busy? Okay, right here is tx ready, so it will return 1 if it's ready. Then if it's busy, it will return 0. Then we have to make a invert. All right, that's it. Check for busy. Then the function for output the data, we use a write function or the USART right here. Okay, Alright, then the data will send to the UART. If you have the LCD or something, you can write or you can modify the put string for LCD. Then this printf function will output to your LCD. Alright, then let's check the printf. Okay, let's say hello world. Let's check it. Alright, then run it again, then hello world. Okay, that's it. So that's how we use the printf function and how we use the MCC for sending the message to the UART or serial port. You can read more on printf function with a parameter or the argument into a functions. In the help file, for example, here you can debug by we have unsigned charge variable my var1 equal to 0, and then you can send the value of my var like my var1 equal to, then you have to make it an argument. Right here is the unsigned decimal integer. It would be percentage of u, right? Then we put it here. Then it will replace the things with a variable. Any variable you put it right behind here. Okay, right behind the string here. Let's check it. I want to increase my var every times the loops. Okay, +1 to check whether the var is increase or not or changing here. It would make the printf change also. Okay, 0 1 2 3. Okay, then if you want to make it the float, you can change it to float. Okay, 0.123 for example. Then you have to change the arguments here for the float. Okay, that's it. Then right here we change to the f, and then we translate it, and then we check it. Oops. Alright, okay, that's it. That's the printf function. Okay, on CCS I will make another videos for you on how to use it. We go to the example or the exercise. Okay, let's programs read from a computer through the serial port and then receive the command. Okay, for example here I want to turn on, then I receive the on 01, okay, number, and then it make the LED turn it on. For example, we can connect the LED. Okay, we have here. Then we program it. I open my pins module. Okay, right here to make the change to the port C for output. Right here, 1 2 3 4 5 6. Okay, and then regenerate it. Okay, then I want to receive. Let's say enter command master. Okay, then we delete this one. Okay, all right, then we receive it by the read command. Okay, but we have to make it a looped. Why something? Then we put the command read, all right, with the variables. Now I want to declare a buffer for chart buffer, okay, as a chart, and then it would be 00000 or something at the initial. Okay, that's my chart buffer, and the other unsigned chart for index. Okay, index something, write this. Okay, just simply make it I for index right here. All right, then I can receive it by assign to this UART read. For the first one, I take the zeros. Okay, for example, I can put here I with I start with 0. Okay, then I increase my I for index equal I plus 1. Okay, and then I take the loops, right? Then what is the end of the string? Right here is the little numbers characters. Okay, then I check if the input buffer, okay, equal or is the little number character, then I would exit my loops. Okay, or it receives so many strings, then I can skip it for this 1 2 3 4 5 6 7 8 or 8. Okay, it would be I less than 9. Okay, and then for example 10. All right, then I would be assigned to 10 to make it exist the loops. All right, then x else increase the I. All right, we have to make sure the data is ready for readings, so we open the function like the UART rx ready, right? We have to check it here. Okay, then we make the checking with another wire for waitings. Okay, if it's not ready, then we wait here, and if it's ready, we read. Then if it exists, then we exist. If it's not, we increase the I until it reaches the end of the string. Okay, that's my case. So every time I start with I equal to 0. Then we can check by print out the string we have received. Okay, the chart buffer. Alright, we can make it like this. Okay, now this time I need to send data, so I make a virtual or emulator connection between my two COM 12 and 13 here is connected together. So I make it connect to the COM pins right here to the 13. And then in my another programs, I connect it to the 12, the same baud rate connected. Alright, then I run my programs. It's enter command appears here with the same here. So for example, on I take it I take it on 01 and then numbers. Alright, then it's respond what I have received here. Okay, then as I explained to you, my charged buffer, okay, in this case 0 should be O, alright, letter O, and my charge number 1 should be N, and my charge number 2 should be 0, my charge number 3 should be 1, and my last charge 4 should be number characters. Okay, that's it. Make it explain to you. Alright, that's it. Then how we gonna check for the numbers here? We have to make a comparison, or we have to declare the other variable for unsigned charged LED on, alright, equal to 0. Then we make it like this. If LED on equal to 1, okay, then we turn on latch bit dot latch C0 equal to 1 to make it on. Okay, else we can copy it to make it to number 2 for the number 2, and number 3, no, it's 1 here, 1 is 1 2, okay, this is 3, alright, and then so on, 4 3 5 6 7 8 9, only 8, 5 6 7 8, okay, and so on, 4 5 6 7, right? We take a checking here, and we have to extract this number. Alright, we take out the buffer number 2. Okay, its buffer number 2 is 0, but it's in character. Then take a look at the number zeros. Is the decimal for 48. So we want to change from character 0 to the number 0. We have to take a minus to 48. Okay, that would make it to the numbers. Then is the tens of a LED on, the LED on. So we take it multiply with 10, and then we take a plus with this one, but is in numbers. Okay, this value should assign to my LED on. Okay, there you go. Alright, then we got the LED on. Let's check it. Okay, alright, this time I don't need this anymore. Let's make it run right here. We have, oops, where my receiver? Okay, enter command and then on 01. Okay, all right, then it take the command and turn it on. For D4 or something, on 04 number. Okay, turn another on. Okay, that's it. There you go. You can control LED. What if we turn on everything? What if the so in the requirements, okay, the asterisk here for turn on everything. So we take it. We take the asterisk here for the buffer number 2. So we take it to the comparison. Okay, asterisk, and then let's see everything turn on 0xFF. Okay, let's check another times. Enter the command on and then asterisk and then this one. Alright, turn on everything. So you got it turn on. You can do the same with turn off and make it blink. That is your exercise number 1. And the exercise number 2, I have already recorded the video. You can check on the course. Okay, I have the program is similar to Guess My Game to make it similar to Guess Your Game. Okay, that is your exercise. You can see my videos and short course for this Guess My Game and change it to the Guess Your Games. Okay, Guess Your Age game. Okay, thank you and see you in next videos.